Okay, so your test is
Monday.
Please, you don't really want to turn this in. Not today. Yes. You're welcome to get that back. If I have time at the end, I will check it off and get everything back to you because I want you to have it all. But you're determined to give it to me regardless. So be it. We very briefly talked about percentiles yesterday, and I think I did one example, the bell rang. So let's talk about that again. Okay, so the z-score, did I tell you, like for years I was calculating the z-score. I didn't know the name was the z-score. We talked about that. Anyway, but anyway, the z-score basically is a way to figure out how many standard deviations a particular score is away from the mean. All right, like we already have that little bell curve drawn out, and the one I have drawn out, it's already labeled by whole numbers. You know, like, so if I made exactly a 92.7, then I would know that I was one standard deviation away, right? But normally we don't make it exactly a 92.7. We're making a 97 or 98 or an 82, and we're falling somewhere in between 0 and 1. And that's what we're going to do. The z-score lets us find out when it's not an exact interval, how many intervals or exactly how many standard deviations you are to the left, to the right. And then with that z-score, if you're in stats, you've already learned how to find percentiles and maybe even z-scores with your calculator a little more quickly. But, and there's a math, like there's some button pushes, and if you want to talk to a stats person, feel free to do that. And you're welcome to do that on a test to calculate your percentile. But I wanted you to see the math behind that, not just some crazy numbers. So I used to teach in linear interpolation to find the z-score, but that's really a little tedious. So what we're going to do is find that z-score and then use our calculator and the integral feature. We are a pre-AP class, and you're going to be doing integrals next year. If you're in BC, you're going to be doing it probably, I don't know, probably as soon as October maybe. And if you're in my class, probably November, assuming me or him or whoever's here next year. But anyway, right here, if you look at this, I redid this year. You jump to this back side that talks about z-score, just to look at these. So like if I said, and I'm using the information from the chart. So I've already found standard deviation. I've already found average. And I use these two rounded values here to make our lives a little easy. If I were you, I would use the as exact as possible. At least take it out to 2 or 3 decimal places here. I think this was 78.70 and this was 14.01. So it was already, this is going to be pretty accurate right there, especially when you're rounding to a couple decimal places. But I would make these as accurate as possible. But the bottom line is your score minus the average over the standard deviation. And if you really think about it, it makes sense. This tells you how far you are away from the mean. And then when you divide it by 14, it breaks that up and tells you how many standard deviations away from the mean that is. And in this case, 14 went into that 17 or whatever it is, 1.16 times. So I'm about 1.16 standard deviations away. So I go to my calculator and I look at this normal curve that I have, right? And there's the mean right there. 1.16 is somewhere right in here. Can y'all see that? 1.16 is somewhere right there. So we're basically using our calculator to find this area. And again, you stats people have other buttons you can push and get there. That's fine. But if you want to learn that from them, great. If you don't, you just go to your second, calculate. What exactly is it? You're going to go to you're going to go to menu, analyze graph, integral. And when you go to menu, analyze graph, integral, you've got to find all the area from the far left to 1.1642. So you just enter a low. Now, to 1.162, I'm going to have to do a little bit extra because if I do 0 to 1.162, it only gives me that part, right? And I really want all of this. So what would you do if you entered 0 as your left and 1.1642 is your right. What would you have to do to that number when you were finished? Add 0.5 to it and then whatever. So that's totally fine, but I gotta be honest with you, to save you a little trouble, remember we talked about almost all the population was within -4 and +4 standard deviations? Well, if you go to -20, you know how little area is to the left of -20? I mean, even -10. This thing gets closer and closer and closer. There's hardly anything between 4 and 5. There's even less between 5 and 6. So if you just go, I'm just going to go from like a -15 or something, just pick something, -10, -15, -20, it doesn't really matter. Bottom line, it's going to be so accurate. You're going to leave off a little area, but you're talking decimals that are like 20, 30 decimal places to the left of the decimal that are completely insignificant when we're rounding to the hundreds. Are you with me? So I just type in something like left bound of -15, right bound of whatever that z-score is, and it goes ahead and finds out that area, and it's going to be more than accurate. Now, if you go -4 to that, you are going to leave a little bit off, and your decimal's going to be out, so you don't want to do that. Are you with me? You got to acknowledge that this curve keeps going forever. But again, less and less, less and less and less as you move out. So that's what I did to get that value. Same thing over here. If I made a 61, don't switch these numbers up. If the 61 is lower than the mean, then you know it landed to the left. You got to make sure you still go score minus average over standard deviation so it shows up negative. But again, when I'm looking at my curve on my calculator, right, there's the average right there. So -1.26 is somewhere over here. 428 or whatever. So again, I want that area. I want to know what percent I am better than. So I'm going to again go menu, analyze graph, calculus, integral, whatever. Get to that integral, left bound, -15 or something like that. Right bound, -1.26. And I'm going to use those and it'll do this little area. And if you get sick of, like once you do an area, you can keep doing calculations over it. But once you have that big area in there, it's just going to put more area and it's not going to look the same. So I always like to go Control Escape to like undo that area. So I always start with a nice clean graph so it looks right. Does that make sense? Okay, that honestly is probably one of the more missed things on the test. And I'm not sure, I think maybe because in the past, I didn't maybe emphasize it like I'm doing right this second. Or maybe in the past, because I wasn't trying to get a video. Am I recording, please? Because I'm not trying to get a video. I just, you know how review days used to be. Hey, good luck on the review. And you would just kind of get together and some of you would work, some of you would waste time and talk about what you're doing this weekend or whatever. But it's not like we talked a lot on review day. So hopefully we're going to do better on that. But on this test, I probably am not going to say, like on this particular one, I'm probably just going to say, what percentile are you in if you have this? I'm not going to ask you for the z-score and then to do it. I'm just going to expect you to know that you need that z-score. Are y'all with me? Okay. Did y'all do the analysis? That I'm sorry, what I call it? The complete analysis of 9 weeks test scores. Did y'all do that and need any? If you did it, did you have any struggles on any part of this? Anything that made you pause, made you think it was tricky? What do y'all think about that mode right there? There's so many modes because so many scores occurred twice. That's garbage. Like when that happens, that's why mode is a pretty crappy measure of central tendency unless you have way more scores than the number of options for the scores. And when you have a test, it ranges. I mean, I'm not going to do this either. Why did I do this? Keep doing that to you.
Is it going to be in order?
What?
Like, is it going to be in order?
I'm going to always put them in order on your test. In fact, I meant to show you this. Hold on. Do I remember how to do this? Let me check one thing. Okay, hold on. Menu. That. That's not it. That's not it. My other calculator. Do y'all know how to, once they're typed in, how to put them in order? Anybody in stats? You know how to do that?
No.
My other calculator, the 84s, I know how to do this. Menu, data. Data capture, no. Table, no. Actions, no. I know there's a way, dang it. Oh, well, it won't. Random, no. List. There's a way.
If you go to menu actions and then sort.
Menu actions. See, I don't have a sort.
Uh-oh.
Mine is not lit up. Oh, maybe I'm on the wrong spot. Maybe I need to go there. Menu actions.
You
Ah.
did it. Wow.
Okay, so here, if they're in a bad order like this, check it out. I knew there was a way to do this.
Menu action. You have to highlight the whole thing.
So check this out. So you need to go and get on scores. So if you go up to the top and say they were in the wrong order, go up to scores and go menu, actions, down at the bottom is 6, sort, and I want to sort ascending. So if they were all on a crazy order and you were just typing them in like you're doing on this problem, like I'm going to hit, just to show you, I'm going to hit descending and I'm going to hit OK, and it'll change the order from high to low. So if you just enter them in bad order, who cares? You can just go up to scores. You have to be on scores, menu, actions, sort, go down to ascending is probably how I would want it. And just hit OK. It'll think for a second and then bam. So that's nice if they are in a bad order. And then you don't have to worry about spending 10 minutes putting them in order. So on this one, you can just type everything in if you haven't done this worksheet yet. Anybody else have anything that they're concerned about, anything they don't know how to do? Yeah.
When it's talking about when you're finding like the percentages and stuff on the normal distribution curve, so like that, how do you know if so like the questions that were like A, B, C on C it asks
Like 13 and 14 down here?
it asks like if it's accurate.
Okay, so let me ask you a question. Let's just say there were 100 people in your scores, right? And can you actually have 34.13% of the people there? No, you could have 34, right? So 34 would be accurate. 35, I would still say 35 is pretty close and pretty accurate, but is it as accurate as it could be? Right? So when this question says, is this as close as possible? Now that's with 100 scores. It's really easy to see that. You don't have 100 scores up here, right? You had 30 scores. And if I have 30 scores, if you really think about it, 34 is about a third. So 30 scores would be what? 10 out of 30 would be exactly 33.3 repeating percent, right? But 11 out of 30 would be about what? Here, 11 out of 30 would be 36. I'll go this way. Would be about 36.6%. So when it comes to saying, is it as accurate as possible? If you got 11 out of 30, which is pretty, I mean, it's in the 30%, right? I mean, that's close, but is it as close as possible? No, because that is a little bit closer to 34, right? This is like 0.8 away, and this is about 2.4, 2.5 away. So when I say as close as possible, I really want you to take what's there. Like this said, how many scores are actually between the negative and the first standard deviation? So negative in the first would be scores between these two. So do you have any scores higher than that, lower than that? Well, you go and you count them all up and you got 18 of them. Now, this said how many. The problem, the test, or the review sheet or worksheet we had before this said what percent of the scores were between them. So if I wanted the percent, instead of how many, I would have just gone and divided by 30, right? And when I divided by 30, 18 divided by 30, I would have gotten 0.6. So that would have told me 0.6 is 60% of the scores. Now the next question is this as close as possible to what the normal curve predicts? Now what did the normal curve predict here? It predicted that, right? So it predicted 68.26%. Well, when I look at this and I look at this, it's close, but the problem is it's not as close as possible. Because if I start checking other numbers like, well, what if it was 19 out of 30? Or what if it was 20 out of 30? I mean, 20 out of 30 is 66.6 repeating, right? That's definitely closer to that than 18 out of 30. So right there, I know that this is not as close as possible. And I didn't even check 21 out of 30. 21 out of 30 is 0.7, so 70%. So when I look at this, 70% is what? Like 1.7 away? This is, I'd have to do the math on that. That looks about 1.66. This looks like about 1.74. So this actually would be a little bit closer. But it would just require you to go and take your calculator out and just see, is your value that you got accurate to what it predicted? As much as possible. I mean, most of the time it's not going to be on a random sample because most situations aren't normal. I mean, they really shouldn't call it the normal standard, the normal distribution curve. They should call it the perfect distribution curve because nothing's really, I mean, it's a predictor. What we normally have is a non-match. It just starts to take that shape under what two conditions? What have I been saying? It's going to look more and more and fit that model more and more as you get more scores and as long as you have an accurate test, right? So the more scores and the more accurate test you have, the more it's going to fit that standard normal distribution curve that everybody calls the bell curve. And if I didn't say this also, I had a professor, we were in a stats class in education. He goes, anybody want me to grade on the curve? And everybody was like, yeah. And I was like, no. I said, well, it depends on where you set your standard deviations or what you're calling. Because the curve, what if I were to take this curve right here? And what if I were to say something like, all right, we're going to make this C. Oh, let me make it uniform. We've got 8 parts here. So what if I said something like, all right, we're going to make this a C. We're going to make this a B. And we're going to make whatever, this an A. We're going to make this a D. And we're going to make this an F. And you spaced everything out from like -4 to 4. Well, if you do, and this is not very spaced out very well because this is a much wider area. So if I really did it accurately, it would be more like this. Maybe, I don't know, maybe something like this, C, this, B, this, A, B, C, D, F. So all these areas, they're not equal, but if they were all equal, the widths, what percent of the class is getting an A? It'd be the area below that curve, right? 0.13 and maybe a 1. Do you really want 1% of this class getting an A? That's nobody. Or that's somebody's arm or whatever. Because 1% of this class isn't even a whole person. There's 20 people in this class roughly, so that's 5% would be a whole person. This is saying this is 13, and you got a little bit of this one and a little bit of this one, so maybe it's 16% of the class gets a B. So 3 people get Bs. Well, that stinks for you, right? That means only the top 4 people are going to get A's and B's. That would mean that if my top scores were 100, 98, 96, 94, 93, 92, 90. This guy's getting a C. Because only the top percentage, it's based on percentages, not your scores. So you could literally make an A but get a C. You probably don't want a curve, unless he makes this the C. That's the C. But also, if you're the worst person in the class, if you're the second worst person in the class, and the worst person has a 20, so he's getting an F. But the next worst person has a 25, you're like, well, this is like F range, so I'm at least passing. Sweet. So it could help you on the low end, but it would just depend on how you set your scale. So it's really a battle, and a lot of professors do that. They're like, I'm only given a certain number of A's, a certain number of B's, a certain number of C's, and they battle it out. Doesn't matter your grade, it just matters your ranking. It's like, what's that show with the girl and the truce or something? What? Insurgent, Divergent, whatever. Okay, remember that when she was fighting? Is it Divergent?
Yeah, it's Divergent.
Divergent? Whatever.
Oh my gosh.
Anyway, do you remember the part where she like joined this faction of these guys who are like rough and tough or whatever, and they had to, and the bottom part, there was like a cutoff line, and you had to make it. If you were below that line, you got kicked out, and you were then factionless or something, and supposedly left to dig in the garbage. I don't know, whatever. But the point is, they graded on a curve. Didn't matter how good you were. You might have been the 30th toughest person on the planet, but if they only took the top 29, you failed. That's how a curve operates. It guarantees a certain percentage in a certain category. What you really want is a scale. You want that high of a 92 and everybody along with it to be bumped to 100. That's what you want. Unless you're that guy that's the second lowest and you're trying not to fail and you're like, ooh, I just passed. But anyway, most people don't want this because it's, I don't know, almost feels like socialism. I don't know, whatever.
What's wrong with that? All right, guys. Just me.
What else? Anybody? Yeah.
When it says like how many standard deviations away from the mean is it? If it's like negative, should we leave the negative in there?
Yes, or say to the right and to the left. And I probably should say standard deviations to the right, but I've just chosen to say positive or negative. You can see like positive, that, and I don't always put the plus in there, but on times where it's negative, I don't know if I did it on this one. I might not have on this one, but yeah, there it is. Negative first and positive first. So yeah, if I got a z-score that was negative, say it's negative, or at the very minimum say, because the z-score would be negative. But if I'm talking about, yeah, I landed one standard deviation to the left, that would be fine to say that. But you would write the z-score as a positive or a negative. But if you're talking about where your score is, you could say it's to the right or to the left of the mean. What else? Anybody else have any issues on anything we've done at this point?
You kind of like briefly go back over regressions, just like,
How to do them?
yeah. Like on
Okay.
a calculator.
So it's kind of similar. Just going to pull up your review. We can walk through it. And y'all remember your 9 weeks test is Wednesday, right? And then we're going to do, if I haven't said this already, we're going to do Pi Day on Monday. And we're going to do limits Thursday and Friday. So just in case
Are we gonna have a test?
limits?
Yeah.
No, I haven't printed out the assignment sheet, but I'm pretty sure, no. So we'll do, I think we come back and we have 3 days. I think we come back and we have a review on some stuff, and then we play the limits game, and then we have a test. So I think the test might be on a Wednesday, if I'm not mistaken.
Is the 9 weeks test like how you do a semester thing where you like problems off of these reviews?
Absolutely. And somebody pointed out there, like, that's kind of put you in a fairly weird spot because we had matrices and I didn't have a review sheet for matrices. So you're going to have to go back through the stuff we did on that, although there are a lot of worksheets we did. So you could look at all those, but there wasn't a formal review sheet. And then on probability this year, there were the review sheets that you did that I pulled from Algebra 2. And there were also the review sheets that were in the book. Well, the ones from Algebra 2 I was using to give you practice, but I pulled everything from the one that was in the book. So you should be okay, I think, focusing more on the ones that were in the book as opposed to all the other ones that were in that packet I gave you. So if there are page numbers at the bottom, maybe look at those more than the rest of it. But yes, that's all I do. So it's probably not, it wouldn't help you at all. I don't want you to do this, but it wouldn't help you at all to look at your tests because the questions for information about the test, because the questions are coming from the reviews. And I'm not trying to kill you on this thing by any stretch. I don't grab all the hardest problems. I just grab kind of more middle of the road kind of stuff.
And there's not gonna be any math stuff on it.
Correct. And then we're gonna come back from spring break and we're gonna take that limits test, and that's gonna give us about 7 days of math team review for that state tournament. So we're gonna go through probably 3 full-length tests in here. I'm gonna ask you to do some work at home so we can talk about it in class and kind of maximize our time. That's really all we're gonna have time for those. And then we have our state tournament on the 10th here at the high school. And y'all, I think I heard about, we have show choir people in here, but there's network and then there's legacy. Do we have legacy people in here? So we don't? Okay, well, then that's probably fine because the network people, I think you have a show choir competition towards the end of the day, but you'll be fine to get out of here at 11. But I think what we're going to do, they have given us permission, if you do need to start earlier on the 10th, to come in and start it at 7:30, so you can get out at 9:30. For some of you, we're going to be able to allow that, not just if you just feel like it, but the issue is they're having is because different tests share problems. Like some of your questions are on the geometry, some of the geometry questions are on yours because yours is comprehensive. Because of that, I can't give any overlap, which means if you come in early to start, you'll go 7:30 to 9:30, but you have to give up your phone and everything until you're ready to leave, and then everybody else is going to go 9, so there'll be no 9 to 11. So there'll be no way for you to like meet them in the hall or whatever. But that being said, that means you can't go to the bathroom. Like they've given us this permission, and I guess I could ignore them, but I'm not going to do that. It's their show, so I'm going to honor that. But so if you do want to do that 7:30 to 9:30, like if you have a baseball game that's early or whatever, you can do it, but make sure you go because I can't let you go. Like even if it's emergency, I'm going to go hold it. Because if you go, I mean, it just kind of compromises everything. There's not going to be like 100 people where I could hand you off to Miss Esslinger and she can walk you to the bathroom, or well, not Miss Esslinger, but some male that can walk you to the bathroom or some female that can walk you to the bathroom. I'm not going to have that. So and I can't let you go and just say, all right, well, I mean, the only thing I could do was tell you to hold it. So if you're not somebody who can hold it 2 hours, then you probably don't want to do the 7:30 to 9:30. All right, so regression.
Are there going to be questions that ask which regression it is where you have to decide, like time and population growth or the depth?
Yeah, but they're pretty similar to the ones we've talked about.
Okay.
So be able to understand the situations we've talked about and then also the graphs we've talked about.
And then on our 9-week test, are we going to have a calculator, or is it going to be like different?
Both. The one page is a calculator page that has 3 problems on it.
Okay,
That's it. So they're like, so I think the problems are like maybe a reduced or echelon form kind of problem. And maybe maybe the one where I gave you a bunch of points and you had to find the cubic equation that fit them. I mean, that might be one. And then the stuff on projectile motion. But I think it's very few topics that we've done that force you to use a calculator. Everything else is non-calculator. All right, so real quickly on your regression question. So I'm looking, I'll just pull out the review. How does it tell me to do this? Okay, so how do I do this regression? So one more time. I would have to pull up my calculator, turn it. I'm going to get out of all this junk that I have. So I'm going to close out the window. Do I want to save it? Yes. Document 1, why not? And then I just open up a new spreadsheet. You know how to do that? Okay, so I open up a new spreadsheet. I'm gonna have to go. There we go. So I'm going to open up a new spreadsheet, and it says, it just gives me these scores. It doesn't really say what they are. So I'm just going to leave them A and B. If you want to come up there and call them X and Y, you can do that. Doesn't really say what they are. So I'm just going to come over here and enter all the X's. I like doing that first. So 2 and then down and then 1 and then down and then 0.3 down, -5, 0, 0, 1, 2, and what else is that? That's it. Okay. And then I'm going to go back up and enter all the Y coordinates. So 2 goes with 4. I'm going to be really careful entering, guys. Every year I have one person or two that enters something in incorrectly. I obviously can't see that. And that leaves them in a bad spot when it comes to getting answers because everything's wrong. And that's really tough. And sometimes if it's really costly, I might say, hey, come back if you still have it stored in my calculator and you can show me that it was one careless error. It's still going to cost you for not being careful. But if it cost you 10 points, I might cut it down to 3 or 4. But you would have to still remain in your calculator. And also, if there is anybody in the other class going, hey, man, let me see your calculator. If you got everything entered in there, I give them a different test than you guys. So it's not like there's any pain in that whatsoever for whatever that's worth. You can tell them that. So once it's in there, I just go back up to the top and I just do the calculator regression. So like for this first one, I'm going to go menu, stats, stat calculations, which is the same thing I did to do stat when I wanted to do one variable stats. This time, instead of doing this like we've been doing the last couple of days, I'm just going to go down there and pick whatever linear regression. I like number 3. I'm going to pick that linear regression. I'm going to hit 3. And then it asks me, where do you want to pull the X list from? Well, I'm going to pull it from X. Where do you want to pull the Y from? I want to pull it from Y. Where do you want to save this function as? Well, why not F1? Nothing else in there. And then I'm going to come down and where do you want to place it? Why not put it in C? And because I already have stuff in A and B. So I hit enter and it spits out my stuff right there. And then I just go now, if I'm asking you to compare like I did on this one, if I'm saying compare these values right here, then I would need to do all the R values. And you're going to see that some of these like quadratics and quartics, they don't have R's, they have R squareds. So you would have to take that R squared value, copy it, and then go take the square root of it to find the R's so that you could actually compare R's. Does that make sense? Okay, and you know how to Control C, Control V to copy and paste? And if I want to do that work, like right here, if I wanted to take this R value, I can Control C. And then if I want to show my work somewhere, I can just add a page, a calculator page. And then I can go, all right, I want to square root Control V. And I can do that pretty easily like that. Oh, you didn't see that. I can just add another page right here by going Control like that and add a page. And, but I didn't want to do that here. All right. Oh yeah, we have Black History Month. So we have that 45-minute video we got to watch. All right, guys, come see me after school. If you need any help or in the morning, I guess. Well, not in the morning, because we don't answer questions like this.
My video.
Everybody else looks smiling.